Section 8.3 talks about variance and standard deviation. Both are used to describe the spread of a data set. So the mean or expected value of a random variable lets us express an important property of the probability distribution. But the knowledge of the location or central tendency of the probability distribution is not enough to give an accurate picture of the distribution. In other words, even though you may know the middle, it doesn't tell you what the overall distribution looks like. So what we're going to start off with is looking at two different histograms. The mean of both histograms is 4. And again, mean is the average value. So the middle, one measure of the middle, is both at 4. But look at how different those distributions are. So the first distribution is what we call more of a normal curve or a bell-shaped distribution, whereas the second distribution is more evenly distributed. So in order to tell us more about how the distribution is, we need some other measures of the spread of the data, and that's where variance and standard deviation come in. So both distributions it talks about has a value or mean of 4. The distribution A is closely concentrated about its mean, meaning that has higher peak is in the mean, whereas the distribution B is widely dispersed. One measure of the degree of the spread is called the variance. So the variance is a measure of how spread out the data is. So we have a formula for it, and we have notation for it. So VAR of X, which stands for variance, is equal to the probability 1 times X1 minus mu quantity squared. Mu, this little symbol here, is MU, and it's a Greek letter, looks like a cursive U. And for us, it's our expected value or average. So it's the average, which is our expected value. And then we're going to add to that the probability 2 of data or outcome number 2 minus mu quantity squared plus all the way up to P sub n times X sub n minus mu quantity squared. So it's a really ugly looking formula. It is much easier to do it in practice than it is to write out the formula. And that's how we're going to find the variance. So let's go ahead and get a distribution on the board and then show you how to find it. So again, remember that this mu is our expected value from the previous lecture. Now, the data table that's on the handout presents the information from left to right. I found, though, in terms of lecturing, it's easier to do my data table going down the page. So as I copy example 1, which asks us to find the variance, I'm going to go down the page. So here's X. And then the next thing I'm going to list is the probability. And then we're going to have another column out here. So we have 1, 2, goes all the way up to 7, 3, 4, 5, 6, and 7. Again, these might be numerical outcomes. I have no idea what the numerical outcomes in this example represent, but they're numerical outcomes. So we have 0.05. We have 0.075, big tiny probability there, 0.2, 0.375, 0.15, 0.1, and 0.05. Okay. So in order to figure out the variance, what we're going to do off to the side somewhere is figure out the expected value. So we need E of X. And again, to get the E of X, what we do is we multiply each value of the numerical outcome times its probability. So that's 1 times the 0.05 plus 2 times its probability, 0.075 plus ... So go off and do that on your calculator. You should find that it comes out to be a nice number in this case. It comes out to be 4. This is a beautiful distribution. It really is in terms of that. Okay, so now what we're going to do is we're going to come in and take each probability and multiply it by the value of X minus 4 quantity squared. So for this first one, we're taking 0.05. We're going to take it 1, that's our X, minus the 4 quantity squared, and then write down what that's equal to. So again, the formula for variance says it's the probability times the difference between each value and the mean squared. And we'll see why we're squaring it in just a second. So if you do that, I have that this comes out to be 0.45. So the next one would be its probability, 0.075 times 2 minus 4 squared. And that comes out to be 0.3. The next one is the 0.2 times the variable x, 3, its value, minus the 4, quantity squared. Notice the 4 is a constant because that is a constant for our formula. And that one comes out to be 0.2. So let me reiterate just to make sure that this 4 is because of the data set itself. It's not always going to be a 4. It's just our data set. Then we have 0.375 times 3 minus 4 squared. And hopefully as you watch this video, you are doing this also. Oops. I'm sorry, that was my mistake. That's 4 minus 4. Well, 4 minus 4 is 0, so this one comes out to be 0, which is okay. Nothing wrong with that. We then have 0.15 times 5 minus 4 squared. Well, that's 5 minus 4 is 1. 1 times anything is 0.5. That one's easy to do. We have 0.1 times 6 minus 4 squared. So 6 minus 4 is 2, squared is 4, times 0.1 is 0.4. And then finally, we'll have 0.05 times 7 minus 4 squared. And if we do that, we end up with 0.45. And what we're going to do is add these together. Now, what we're doing is averaging the spread of the data. So we're really looking at how far one is away from the middle. So 1 minus 4 is the distance between 1 and the middle. The problem is that it's on the left side. If I do 1 minus 4, I get a negative. And the negative distances on the left would outweigh or cancel out the positive distances on the right. So the reason you're squaring it is to get rid of the sign when you do that subtraction. The 0.05 is taking into account how many of these you have. The 1 occurs 5% of the time. The 3 occurs 20% of the time. So that's why you're multiplying it by the probability, because it's dealing with the frequency of each of those numbers. Okay, so now what we're going to do is we're going to add all of these together. So then the variance says to now find the sum. So we need to add those together. So the variance is equal to the sum of what we just found. The column. And if you sum that column, we get 1.95. So that is one way of talking about how spread out our data is, 1.95. So closely, usually we work with the square root of the variance, which is called the standard deviation. So the standard deviation, and we're going to use this symbol, which is a rho, which is a sigma. So this is a sigma. And you can either draw it like that because it's easiest. Your book tends to make it look more like that. So, and that is the square root of the variance. And that's the standard deviation. So for this example, that would be the square root of 1.95, which comes out to be 1.39. And on the handout, this is labeled as example 2. It asks us to find the standard deviation. We need standard deviation when we come back into a later section to talk about the normal curve.